Okay, today we are going to continue with those integers. Last week we talked about multiplying integers. This week we're talking about dividing them. They have rules attached to it also. We were getting confused last week on the like signs and the different signs and what you do when you add or subtract and how it's different when we were multiplying. So when you're adding and subtracting, the rules are different than the multiplying and dividing rules. If we look at some of our definitions here, let's look what it says. The mean is the sum of the values in a data set divided by the number of values. That's on our math packet that we're working on. Some of us are having a hard time finding that mean. You add them all up and then count how many numbers there are and divide by that number. There's actually quite a few of us forgot to do the division. So don't forget when you're finding the mean, you add them all up, but then you have to divide by how many numbers you added. Now there's the rules to dividing integers. If there are the same signs, of course my pen is not working right now. So if there are the same signs, that is the quotient of two integers with the same sign is positive. So if you have two positives or two negatives that you are dividing, the answer will be, that quotient will be a negative. If they are different signs, if you're dividing a positive by a negative or a negative by a positive, then the answer will be negative. So we have to look, just like when we were multiplying, it's the same rules. Same thing with our zero rule. The quotient of zero and any non-zero integer, it shouldn't say any non-zero integer is zero. So just like when you multiply by a zero, the answer is zero. When you divide by a zero, the answer is zero. So now let's look at how we're going to fill in our table here. We have our division equation. 18 divided by 9 equals what? And then what times 9 equals 18? So we have our fact families. If we have 18 divided by 9, what would that equal? That equals 2. So what times 9 would equal 18? 2. Very good. And your quotient is always, a quotient is the answer of division problem. So the quotient would be 18 divided by 9 is 2. So if you're not sure off the top of your head, 15 divided by 5, you're going to want to look and see, well, 5 times what equals 15? So what would that be, Zoe?
3.
Yeah, so it's 5 times 3 equals 15. So we know that our quotient is going to be that 3. Is it going to be a positive or a negative 3? Tristan?
Negative.
Why would it be negative?
Because it has negative 15 divided by 5.
Yeah, we have a negative divided by a positive. And when you have different signs, your answer is going to be negative. The problem on top, we had 2 positives, so our answer was positive. So let's look at our next one. Negative 14 divided by 7. So we have to ask ourselves, what times 7 equals 14? So what times 7 would equal 14? Nolan?
2.
2. So our quotient is going to be that 2. Now we have to look, is it going to be a positive or a negative? What do you think, Peyton?
Negative.
Why would it be negative?
Because it's negative 14. And if this number is negative, the
Say that again one more time.
Since it's negative 14, if it was negative 7, it wouldn't be negative. But since it's negative 14, it was.
So if it's a positive 14 divided by a negative 7, what would our answer be?
Still a negative.
Yeah, because we have different signs. So we have one is a negative and one is a positive. Our answer will be negative. So look at our next one. 10 divided by negative 2. So look at the flip side. 2, what times 2 equals 10? So what times 2 equals 10, Penelope? 5. So our quotient we know will be a 5. Is it going to be positive or negative, Penelope? Why is it negative?
Because 10 is positive and the 2 is negative.
Yeah, because we have different signs. We have that positive and the negative. So our answer is negative. Now we have negative 12 divided by negative 4. So what times that 4 equals 12? Ryan?
6 times. My bad. 3 times 4.
3 times 4 equals 12. So we know our quotient is going to be that 3. Is it going to be a positive or a negative, Ryan?
It's going to be a negative.
Why would it be negative?
Oh, wait, my bad.
Why is it a positive?
Because both of them are negative.
Yeah, they're both the same sign. We have a negative divided by a negative, so our answer will be positive. Nick, do you have a question?
No, I'm good.
Okay. So let's look at example 1 here. We have 28 divided by 4 equals negative 7. Again, you can see we have that positive divided by our negative equals a negative. Then we have negative 60, and it's a fraction. Negative 60 with our fraction line, negative 12. What does that fraction bar tell us, Tristan? To divide. So this fraction bar means divide. So negative 60 over negative 12 means negative 60 divided by negative 12. So we know 60 divided by 12 is 5. Negative divided by negative is a positive. And C is one of those easy ones. There's a 0. 0 divided by something is always going to be what? 0. So your answer will always be 0 if it's 0 divided by something. So now let's look at example 2. The data shows the high temperatures for 5 days in January in Bangor, Maine. Which expression can be used to find the average daily high temperature? So we've got 3 degrees Celsius, negative 3 degrees Celsius, negative 5 degrees Celsius, 2 degrees Celsius, and negative 7 degrees Celsius. Which one of these expressions correctly tells us how to find the average temperature? Remember that average means the mean. So what do we have to do to find the mean? What do you think, Anthony?
You add them all up
Why would we divide by 2?
Oh no, wait, no, not 2. Like how many numbers there are?
Yeah, so there's 1, 2, 3, 4, 5. So we know we want to divide by 5, right? Because there's 5 numbers. So we have to add them all up. But look, some are positive and some are negative. So what do we need to see in our expression? We need to see some positives and negatives. So if these are all positive, is it using the correct numbers? No, so it can't be A. Look at B. These are all positive. Is it using the correct numbers? No, we need to have some negatives. Now this one, we see there's some positives and some negatives. We see the divided by 5, and we see that there's these brackets. Let's look at D. We've got our positives and negatives divided by 5. So they're almost the exact same. how do we know is the correct expression C or D? What do you think, Penelope?
I think it's C because it shows how you do Monday plus Tuesday plus Wednesday plus Thursday plus Friday, and then it shows how you divide it by 5. And then it also shows that the answer. Oh, wait.
So isn't that the same thing we're doing for D? Monday plus Tuesday plus Wednesday plus Thursday plus Friday divided by 5?
But indeed, it have a lot of them say that they are. Oh wait, I think I didn't look at some of the negative symbols.
Okay. So they have the same positives and negatives. What is different about C and D? Nick?
Oh, one of them has like a little.
The brackets?
Yeah, black.
Why would those brackets be important, Brielle?
Because you have to add all of those numbers before you can divide.
Remember, Perm does. The first thing is parentheses. You do whatever's in the parentheses. Then you do exponents and radicals. Then you multiply and divide. Then you add and subtract. So if we were to look at D, the first thing we would do would be dividing. -7 divided by 5. Is that what we want to do when we find the average? No, the first thing we want to do is add all of our numbers together. So that's why they put these brackets there. It's like a double set of parentheses. So that's what you do first, whatever's inside. So we do our adding and subtracting. Then we divide by 5. So you always want to look at that order of operations. What do we do first? Now let's look at example 3. We want to convert Celsius to Fahrenheit and convert Fahrenheit to Celsius. And the formula for doing that, to go from Celsius to Fahrenheit, is you want to do 9/5 of the Celsius plus 32. And to find the Celsius, you do the opposite. So instead of 9/5, you do 5/9 times the Fahrenheit minus 32. We are going to be seeing that in our workbook pages, how to use those formulas. So it's important that you know this formula for when we get to our workbook pages. So you can plug in the Celsius, and you know it's 9/5 times the Celsius or 5/9 times the Fahrenheit. But look at the parentheses here for the Celsius. We want to make sure that we're plugging in that Fahrenheit and subtract it by 32, then multiply. Okay. Let's look at our workbook pages for today and see what we're doing for our workbook pages. So we can see our first set of problems. We have just doing that division. So you need to, if you don't know what 66 divided by 11 is, think about that opposite. 11 times what equals 66? And then you have to look, is this going to be positive or negative? So what is 66 divided by 11? Maya? 6. And is it going to be positive or negative, Anthony?
Negative.
Why would it be negative, Anthony?
They both have different signs.
There's different signs. We see there's a negative and there's a positive. So our answer is going to be negative. Our next set of problems says find the mean of the integers. What do I have to do to find our mean, Tristan?
First, you have to put them in order.
To find the mean, does it matter the order? No. That's when we're looking for the mode and the median.
You have to add all of them up and then divide them by the number of integers.
Yeah, so I'm going to add them all up. So -5 plus 0 plus 2 plus 3. And then I'm going to divide it by 1, 2, 3, 4. So you add them all up and then you divide it by how many numbers there were. Then we see at the bottom, we've got that converting from Celsius to Fahrenheit and Fahrenheit to Celsius. They're giving us the formulas on the workbook page. So we have it in our notebook and we have it on the workbook page. So if they're giving us the Celsius, we want to find the Fahrenheit. So if you want to find the Fahrenheit, you're going to plug it in to that formula. 9/5 times negative 45 plus 32. So who remembers how I would do 9/5 times 45? Anthony?
So I think you just make it like 45 over 1.
Yep, we make that whole number into a fraction. And then how do I multiply?
You have to make them the same.
That is adding or subtracting. We have to make it a common denominator. Multiplying and dividing, you do not need a common denominator. Anthony?
Just times the top by the top and bottom.
Yep, you multiply the numerators and you multiply the denominators. So I need to do 9 times 45. I can do it as mental math, or I can multiply over on the side. 5 times 9 is 45. 9 times 4 is 36. Plus 4 is 405. And then I have 5 times 1, which is 5. I don't want to leave it as a fraction. So I want to make it as simplified as I can. I'm not going to leave it as that fraction. So remember that fraction bar means divide. So 405 divided by 5. I can do it in my head, or I can do the long division of 405 divided by 5. 5 goes into 4 0 times. 5 goes into 40 8 times. 8 times 5 is 40. So I subtract it. I bring down my 5. 5 goes into 5 one time. 5 times 1 is 5. 5 minus 5 is 0. So my answer would be 81 degrees Celsius. 81 degrees Fahrenheit. We had Celsius and we're going to Fahrenheit. Do you guys see how we got that? On the back side, you need to fill in the missing numbers, filling in what M is, and then solving it. Here in this section, you need to say is the left side, you have to evaluate both sides of the expressions to know is it less than or greater than or equal to. So you have to do the math for both sides and decide if the answer on one side is a negative and the answer on the other side is a positive. We know that negatives are small, positives are big. So it's going to help you if you're paying attention to which side is negative and which side is positive. Remember, when you're going to the left on the number line, as those negative numbers look like they're getting bigger, they're actually getting smaller. -9 is smaller than -2. But when you're going to the right of 0, 2 is smaller than a +9. So remember, it depends. If you're going to the left, the numbers are getting smaller. If you're going to the right, the numbers are getting bigger. And then you're going to work on those word problems. We have time in class to work on this. So we're going to work calm and quiet.